Hello. Today we're going to be talking about TLS negotiation, and this is going to be a follow-up video from a previous topic of certificates. So basically, setting up or talking about the TLS handshake and negotiation process is going to revolve around a few different key messages or packets. And to be very clear, when we're talking about TLS negotiation, what goes hand in hand with that is something called encryption, right? So when we are looking at any secure connection, and it could be anything from accessing a internal website or going to your bank's website, those connections are going to be encrypted so that only the two people at either end of that connection should have or should be able to see the actual data or the application content within that particular connection. So encryption is a way to protect a connection from outside third-party actors. Now, when talking about or discussing the actual handshake itself, as I mentioned before, there are a couple of very key packets that have to be sent or that have to be traversed through the network in order to enable and allow this handshake process to work. These particular packets are your client hello, your server hello, your certificate, your server hello done, your client key exchange, and then your change cipher spec. These are all specific packets that are sent out over the network to begin establishing and creating that secure connection. Now, we are going to look at each of these different messages, packets in the coming sections, but there is like a very quick summary here that kind of describes what each of these different packets is used for. So, to start with, we have what's called the client hello packet. So the client hello is arguably the most core TLS handshake message because it's how the connection is initiated or how we start the actual handshaking process. So the client hello packet is basically one that is going to be created or generated by any type of element within a network. It could be a phone, it could be a browser, it could be, you know, a computer or a laptop. It's basically any element in the environment that is going to initiate or wants to create a secure connection. They will be responsible for creating this client hello packet. Now, if you were to look at this client hello packet in some kind of tracing tool, there's all kinds of different details and all kinds of information that's contained within the client hello packet, but there are a couple of very important details or pieces of data that is included within the client hello. These are going to be things like the TLS version, the supported cipher suites for the actual encryption process, and it also is going to importantly include something called the client random. So the client random is simply a, well, randomly generated number. Usually it's quite large. The bytes that are dedicated to the client random are 46 bytes within this hello packet. It's going to be dedicated towards the client random. And this client random is going to be used later on in the negotiation process to actually secure the connection. So kind of putting all of this together, the client hello packet is how a TLS connection is initially negotiated. It includes all of the various supported cipher suites, TLS version, and so on that are compatible with the client sending it. Now, to go along with the client hello, we have what's called the server hello. And the server hello basically fills a very similar role to the client hello, except that it's going to deal with the details from the server's perspective. Now, one of the biggest differences between the client hello and the server hello is that rather than the server providing back to the client all of its supported options, capabilities, and so on, the server hello, what it will do is it will basically be the response the server generates to the client hello. So the client sends out all of the various options and capabilities the client supports. The server will then basically look through all of those different options and select whichever ones are most secure or most compatible. So if you have a particular client that has the latest and greatest cipher suites available to it, if the server also supports those same latest and greatest cipher suites, the server will select one of those as its option or its selection. So the client sends out all of the available or compatible options that it supports. The server chooses from those available options, and that will basically set up the basic encryption and security details that will be used for this particular encrypted connection. One other very important piece of information that is going to be contained within the server hello is going to be the server random, which once again, the server random is a counterpart to the client random. It is again a very large random number, and this very large random number, the server random, is sent back to the client. So now, when we're setting up and establishing this TLS connection, the client and the server will both utilize or both have access to now the client random and the server random. That's one of the details that is sent out through the server hello packet. Now, I do mention here as well something called the server hello done packet. This is basically a message that is sent out once the initial exchange of handshake messages is completed. There is one additional packet that will be sent out before the server hello done is sent out, and that's the certificate. We'll talk about that in the next section, but I did want to quickly mention here that the client will send out its client hello, the server will send out its server hello, and then the server will also send out its certificate packet. Once those messages are exchanged, the server will then also send out a server hello done packet, because at that point in this connection, we've basically established, created, agreed upon, negotiated the various details that will be needed to secure or encrypt this particular connection. As I just mentioned, one of the other packets that is also exchanged during this initial setup is the certificate, and to be clear, we're talking here about the server certificate. In our previous video, we talked about some of the details that are going to be included inside of the actual certificate itself. You know, the valid to, valid from, subject, issuer lines. So there are all of those same details are going to be collected together and are going to be provided to the client when the server sends out its certificate packet. Now, upon receipt of this certificate packet, the client is going to run a validation test on the certificate. It's going to check, among other things, whether or not the certificate is valid, and importantly, whether or not the client trusts all of the certificate authorities that are included within a given certificate's chain of trust. This is very, very important because certificates are used as a way for a server to say or to confirm that they are who they are describing themselves to be. And part of that validation process is the client will check the certificate authorities within the chain of trust for the certificate and ensure that those certificate authorities are added into the client's local trust store. This is an absolutely key part of the TLS negotiation and handshake process. If for some reason the client is unable to validate the certificate, perhaps because there's a missing certificate authority in the trust store, or perhaps because the certificate is not valid, in that particular case, the entire handshake will fail and the secure connection will not be established. Now, once we have the client and server hello packets exchanged once the certificate has come across and has been validated, and we also have that server hello done packet has been shared. The next step is for the client to utilize one of the fields within the certificate, specifically the public key within that certificate. And what the client is going to do with that public key is it's going to use it to encrypt a third random number, which is known as the pre-master secret. The client uses the public key to encrypt this pre-master secret and send it onwards or send it forward to the server. And the server and client will now have a total of 3 randomly generated numbers: the client random, the server random, and the pre-master secret. Now that both sides have these 3 large random numbers, what they will do separately is they will utilize a series of complex mathematical algorithms, and they will separately generate the same master secret key. So the reason that this is being done is up until this point in the connection, where the only encrypted traffic that has been sent across is that pre-master secret, and it was encrypted with the server's public key and then decrypted with the server's private key. This is what's described as asymmetrical encryption, where you are using 2 different keys to either encrypt or decrypt. In our particular case, the public key is only used in one direction. It's only used for encrypting traffic. But the server can then use a different key, the private key, to decrypt that traffic. And in particular, it's using the private key to decrypt the pre-master secret that the client created and generated. So what I've just described there again is what's called asymmetrical encryption, where you have 2 different keys that are being used to encrypt or decrypt data and traffic. The whole purpose behind the client and the server using these 3 large randomly generated numbers to calculate a master secret key is because the goal is to switch this connection from asymmetrical encryption to symmetrical. Why would we do this? The primary reason is that it saves on load being utilized on a server or a client. Asymmetrical encryption can be more secure, but that comes at the cost of processing power and resource utilization. Switching from asymmetric to symmetric encryption takes some of that load off. And because the symmetric encryption details were initially encrypted using the public key and the private key, it makes the symmetric encryption channel not only less load on the individual elements within the connection, but it also makes the connection itself more secure, because again, the symmetric encryption details, which again is made up of that pre-master secret that was initially encrypted, it actually makes that connection even more secure, because anybody from the outside would not be able to get into it, wouldn't be able to see that pre-master secret because it was sent over the connection encrypted via the server's public key. So if we take the previous sections and kind of put them all together in kind of one slide, the client in a TLS handshake will initially send out a client hello. The server will respond to that client hello with the server hello. The server will then follow up with the sending of its own identity certificate. And then the server will send out a server hello done packet indicating that this initial exchange of messages has been completed. The next step down, the client will send out its client key exchange packet, and this is where the client has encrypted the pre-master secret using the server's public key, which the client got through the server's certificate, and it has sent that over a connection or over the connection in an encrypted fashion. The server will decrypt the pre-master secret using the server's local private key. And the last line here where we're talking about the change cipher spec, this is where the connection is going to be changed from using asymmetrical encryption to symmetrical encryption, because now both sides have the client random, server random, and the pre-master secret, and they use those specific random numbers to generate the master secret shared key that will be used for the remainder of this particular connection. Okay, so I know that that was a lot of information, so I'll try and boil this down just a little bit more. TLS negotiation is built on the exchange of messages to share supported encryption options. The combination of the client and server hellos will be used to exchange the client and server randoms. Once the client in these connections receives the identity certificate for the server, it will use the public key within the certificate to encrypt a third random number, the pre-master secret. And then once both sides have the client random, the server random, and the pre-master secret, those three numbers are used together to generate a master secret key to enable symmetric encryption, and it will be used for the remainder of that particular connection. I'd like to thank everybody for joining our session today, and we will see you in the next one.